going to talk about this whole concept of a quantitative sales forecasting. Now, it tends to be figures for sales that we're looking at, and if you remember from the very first part of the syllabus, we did sales forecasting in year 1, and we said, well, what's the purpose of it, and then what are the factors that affect it. So there's 3 major factors that affect our forecast of the future, and then what are the difficulties involved in it. So that was done in year 1, but then in year 2 we have to calculate some time series analysis, and it's simply called a moving average, and you have to do a 3-period and a 4-quarter one, and then you've got to interpret it as well and put in a line of best fit, and then extrapolate it, that past data, into the future. So in other words, you've got some past data, and we're saying, well, how is that going to be moved forwards into the future, and then that gives us the basis of our forecast for what the future sales might be, and then what are the limitations. But we're just going to basically do these first 2 here in this video, and then we'll look at the limitations in another video. Okay, now the exam board give us as teachers what they call a getting started guide, which gives us an idea. It's on the website, you can download it, and it just tells us what you have to do to teach this topic. And they say you need to be able to calculate a 3-period and a 4-quarter. I'll explain what that means, but those are basically cycles. So there might be some sales which are, moving into a 3-year cycle. So they do well in the first year, even better, better still, and then they drop off and do well, and even better, drop off, do well, even better. You'll see that when I give you the table. And you also have a 4-quarter, which is more when the sales are split into the quarters of the year, and you might say, well, if it's sun cream notion, then obviously sales in the winter, 1st quarter might not be very big, sales in the 2nd quarter are starting to build, 3rd quarter they're at a peak, and then the 4th quarter they drop off again. Okay, so you've got to be able to move those things, and you have to calculate a cyclical and an average variation. So a cyclical variation and an average variation. So there's 2 types of calculation that are needed, so be careful when you do it, you'll see that. And then you'll use that to extrapolate, because you'll use a line of best fit here, and you'll move that line forward to say, well, if this is what's been happening in the past, I can now have a good estimate of the future by what's happened in the past. Okay, and then recognize later on that there's no guarantee of that. But you do have to do a line of best fit, and you have to do a limited number. It does say limited number, but you have to do calculations. So they tend to produce a table, and they've done some for you, and then you have to fill in 2 or 3 missing boxes. And then you have to interpret those as well in a business context. So that's quite important that you can interpret those. And then recognizing the limitations that past performance is no guarantee of the future, and also the fact that there's other things that are happening, additional factors such as SWOT and PESTLE here. And so that's basically what we're going to start to do now. So as I say, here you have your actual set of data, and this is a 3-period moving average. So you can see, and I've done it in color coordination for you, you have a £17,000 worth of sales, building to 18, building to 20, and then dropping off again, but then building again, dropping off, building, dropping off, building, etc. So you'll always be identifying that in the actual data, and then identify the cycles as the next bit. So you can see here that this is the first cycle, these first years, and then that's the second cycle, and that's the third cycle, and you move on down the data. Okay, now what you then have to do is you have to work out the moving average for that data in order to smooth it. So this is quite has lots of peaks and troughs in it, and it'll become clearer when you see the graph of this, and the idea behind this is that you smooth it out and you get what we call a trend line of data. So in other words, because this is quite peaky and troughy, we smooth all this data out by working out these moving averages, then you find that trend line and you extrapolate it forward just by using your eye. Okay, there are other methods, and in another video I'll show you those as well. Okay, so this is the data plotted for you, and you can see that, you know, it's got lots of peaks and troughs in it. So what we recognize is that that first 3 years is a cycle, okay, and that is shown here. The second 3 years then, 13, 14, 15, that's another cycle. There it is. And then you've got a third cycle, and on you go. So these here, 2010, 11, 12, oh, then it drops off a bit, goes up a bit, drops off, goes up, drops off, goes up, drops off, goes up. And it's this that we're trying to forecast what's happening after 2023. Okay, so this is the trend line. This is a smoothed out line that you could draw by eye if you wanted to through the data, but it's not good enough in the year 2 to do that by eye. We've got to work out what that trend line actually is. What are those numbers on that trend line? And you do it by working out the moving averages. Okay, so this is how you do it. So step 1, you work out the average of the first 3. So you start at the beginning, 1, 2, 3, and you work out therefore 2010, 11, 12, and what's the average of those 3 numbers, and you're going to see hopefully that it's sort of centered around there. So in other words, 10, 11 and 12, you are going to put your number in here, and it's going to be 18.3, which is 17 plus 18 plus 20 divided by 3. Once you've got that, you move forward. So step 2, okay, sorry, step 3, you move forward and work out the average of the second, third and fourth piece of data. So 1, 2, 3. So you're now going to work out the averages of those numbers there. There they are, and hopefully you can see that because it's here, it's going to get centered quite neatly on 2012. And once you've done that, you just continue to move forward, center it there, and get 20. So 20 is the result of the average of 20, 19 and 21. So if I said to you, what's the trend line down, say here, 2018, you'd say, well, I need to find here, I need to work out the average of 25, 27 and 25, and I put the answer in here. And that's what you know by a moving average. You're doing an average, but you're moving it forward by one piece of data at a time. Hopefully that's clear how you do that. And in the next table, I've actually done it for you, and I've graphed it. So here's your trend line. So these are all the moving averages. Okay, so 25.7 here was the average of 25, 27, 25. Okay, 28.9 was the average, was the average of 27, 30, 29. So all those 3 get centered here. And so the red line is the trend line, and I plotted it on the graph for you so that you can see that it sort of smooths out, not exactly, but it smooths out the data. So it's not a straight line, but it will smooth out the data, and that's going to be useful because what we're going to do is we're going to extrapolate that. We're going to say, well, look, if it's done that over time, it's going to continue to do that. Okay, that's the essence of what we're doing here. So the next part of the game is to now work out the variation that's happening in every year. So in 2011, hopefully you can see that the actual data is below the trend line. The actual data below the trend line. So you work out this variation for each of those years by saying 18 minus 18.3 gives me an answer of minus 0.3, and it's really important that you get these minuses correct. Okay, so 23 minus 24 gives me minus 1. Take this one, 27 minus 27.3, 0.3. So hopefully that does make sense to you. So that's your second step. You work out the trend line first by doing the moving average, then you do your variation. Now, why do I have to do that? Well, because what you can see is that in the second year of these cycles, in green here, those green ones are all the second years, okay? In the second year, the variation is always below, apart from that one, always below the trend line, rather, is always, sorry, the actual data is always below the trend line. So when I forecast this trend line forward, my forecast for the actual is going to be below the trend line, because it always is below, apart from that anomaly there, it is always below in the second year of the cycle. Just increase the size of that graph for you. This one here, 2011, in the second year of the cycle, the actual is below it, but in the third year of the cycle, the actual is above your trend. So here's your trend, and the actual is here, look. So that's your second year, third year. Now we go to the first year again, which I haven't worked out yet. Then I go to the second year, it's below it, and then the third part of that cycle is above again. So you can see that that's quite important, that you're getting these, is it above it or below it, by looking at those, the sign of the variation. So what I do is we will take the second year, and you can see it's minus, minus, naught, minus. In other words, in the second year, the actual is always below the trend. So I want to work out now the average of those numbers. So I take those numbers, add them up, and take the average. In other words, the average of those four here is 0.9 minus 0.9 divided by 4 gives me minus 0.225. And that's really important, because when I move this trend line forward in the future, and I say what's my forecast for this second year, it's going to be basically the trend line minus 0.225. Okay, you'll see then in the next one that the third year within that cycle is always plus 1, 1.3, 1.3, 1.3. So it's always above. So I'll take the average of 1, 1.3, 1.3, 1.3, get an average of those. Then that will give me what I have to do if I'm forecasting into the future. So you can see this is quite complicated, but in the next video I'll go through an example with you again. And then you do the same for the first year. And you can see in the first year tends to be below the trend line. So that's what we've got there, and there are some that are the actual is below. So the green ones here, although you haven't done one for that one, the green ones here are below the trend, and there are some that are above the trend. And the reason for that is that if I then show you this is the moving average, this is the trend line, and I moved it forward. Now I'm going to move that forward. So by eye, I just put a ruler through that, and I will add a line there. So this is now my forecast, the trend for 23, 24, 25, 26, 27. So this is my trend line. But there are some of those periods, so these here, the last one of those, remember these are the last parts of those periods, and they're always above trend. So if I knew the average of what it is above the trend, I'd tell you, work out the trend by reading it across here on this axis, add them to that some number, this number here, which is the number that has that you've already worked out when you've done your average of those variations. So hopefully that's clear. You work out the moving average for the data to smooth it. It's known as a trend line. You extrapolate it forward by eye. You then calculate the variation for each data point by deducting the trend from the actual, so it's actual minus trend. Then you use those to calculate the average for each of those periods in the cycle, the first year, the second year, or the third year of that cycle. And then you put that on. Once you've done that, you put that on to this extrapolated trend line. And in the next video, I'll just give you an example. I might even use that same table, and we'll do it again using that table. So hopefully that shows you how to do quantitative sales forecasting.